Okay, so we would be trying to solve this question, and it's an interesting question. And I'll tell you that I have not solved this question before, so there might be mistakes that we can do, but let's do it. Let's try to figure out how the question is solved so that we can know how to solve the question. So first of all, we read the question. It says there is a uniform rod of mass m. So there is a rod, and let's decrease the size of this. So they say there is a uniform rod of mass m and length a lies on a smooth horizontal plane. Okay, a particle of mass m moving at speed v perpendicular to the length of the rod strikes it at a distance a by 4 from the center and stops after collision. One thing that my mind read, that there is a collision kind of thing that is happening, and this collision, and when we consider two particle system, when there is a rod and there is a particle, then in this two particle system there is no external force that is being applied. All the force that is being applied is with the inside the two particle system. So if my two particle system is rod plus this whatever particle, say it is a ball, rod plus ball. So this is a rod, and the plane of this blackboard screen is my smoothless horizontal table. Here it is the center mass or center of mass of this. There is a mass m is given, and there is a small mass of the particle. This is the length of the whole rod, and this is there is something also, v is also given, the speed of. Now what will happen, that there is a ball which came, so particle was here having a mass m, speed v, and now it strike the, and this particle is striking the ball, striking the rod at this particular point. Let this point be a and let this point be b. Now what is happening, this is what is happening, and this is how we have to, so these kind of questions which are kind of little bit difficult, so you need to have patience with them. So you need to understand what they are asking us to find: the velocity of center of rod, any velocity of a point of rod. This is the thing that they're asking. So there's something asking velocity, so you have to start wondering about it. And angular velocity of rod about its center just after the angular velocity of rod and about a after collision, just after collision. This is the thing that they are asking. तो यार मुझे लग रहा है पता है कोलिजन हुआ है, तो कुछ कुछ चीज़ें हैं, और अगर मैं इसे टू पार्ट पूरे उसको एक मैं सिस्टम मान लूँ, if I consider whole of this entire two bodies as a system, two particle system, then I know that there is no external force that is being applied. So conservation of linear momentum is there, right? Conservation of linear momentum is there, and there's some talk of conservation of energy also that could go on in my things, that in my head, that there could be a conservation of energy. Now imagine what would happen. So there would be a translatory motion of the rod. When the particle is hit, the particle stops after hitting, and there will be a translatory motion of the rod, and there will be some rotational motion of the rod about a only. That is what there's. For example, just after the collision, the kinetic energy, so the rotational kinetic energy will be this, and there will be a translational kinetic energy, which I can write it as VCM. This is what I have to find out, center of mass point. And this whole kind will be is transferred from where initially it was the rest. So this is the formula for conservation of energy, which is applicable in such a situation. But will I be able to solve something? So the thing is, whenever you see a question, there will be different kinds of approaches that will come into your head. So you need to figure out that would I be able to solve whatever they have asked from in the problem. So first of all, they have given these two variables. The answer will be in the variables. So they were given these four variables. Now m you know, v you know, I for the rod you know, about which point you are asking, if you're asking moment of inertia about A, and that's what they might be interested in, that is m a square by 12. If they asked about B, then also you can do things m square by theorem of parallel axis लगा के you can calculate the moment of inertia B. I'm not calculating. तो ये मुझे पता है. ओमेगा इज़ द एंगुलर वेलोसिटी, जस्ट दिस दे हैव आस्क्ड मी. एम पता है, वी सी एम पता है. तो इसमें आई हैव दिस इज़ अ इक्वेशन बिटवीन ओमेगा एंड वी सी एम आर टू. I can find a relation between these two things. Can we get another equation where we can have an omega or VCM? Then the question is solved. If approach is fine, if this concept is fine, then it works, right? And I have different ideas about it. Now, what else I can apply? So if it's a two-particle system, conservation of energy works. It's a collision. Conservation of energy work. Although they have not mentioned very clearly what kind of collision is, but it's mostly elastic collision. Conservation of momentum or something can we apply? Can we apply conservation of momentum? तो इनिशियली क्या है, इक्वल्स टू से पहले लिखेंगे. फर्स्ट ऑफ ऑल व्हाट इज़ द मोमेंटम कंजर्व. मोमेंटम क्या पहले, इस पार्टिकल का क्या मोमेंटम था कोलिजन से पहले, एम भी था यार, और मैं सिर्फ एक्स डायरेक्शन मोमेंटम ले रहा हूँ. और इस पार्टिकल क्या था, ज़ीरो था यार, है ना. एंगुलर मोमेंटम की बात नहीं कर रहा हूँ, लीनियर मोमेंटम, कंजर्वेशन ऑफ लीनियर मोमेंटम लिखना नहीं है, लिख नहीं रहा मैं. एंड देन आफ्टर दैट, आफ्टर द कोलिजन, सो दिस, जब भी मैं ऐसे लिखूंगा तो ये बिफोर कोलिजन है. आफ्टर द कोलिजन क्या होगा, ये पार्टिकल पहली बॉडी तो रुक गई, दिस बॉडी स्टॉप्स. सेकेंड बॉडी कैसा मोमेंटम कर रही है, इट मूव्स इन द सेंटर, तो एम वी सी एम, राइट. तो ये आ रहा है. और कुछ है, रोटेशनल मोमेंटम भी जाएगा ना, तो वो भी इंक्लूड करना पड़ेगा. यू कांट जस्ट इग्नोर दैट. सो व्हाट इज the conservation of angular momentum, maybe you can include it. So conservation of linear momentum की जगह I guess conservation of angular momentum would make more sense. I'm not sure about this. So we are not sure about this thing. We are not sure about this. Let's try conservation of angular momentum. उसके लिए I can imagine that there is a point here. For example, this is the center point that I am considering. This is the, उसके हिसाब से I am calculating angular momentum. The angular momentum of this particle क्या होता है, एंगुलर मोमेंटम. एंगुलर मोमेंटम ऑफ अ पार्टिकल इज आर, रिजिड बॉडी की बात नहीं कर रहा, आर क्रॉस पी. तो आर इज पोजीशन वेक्टर फ्रॉम दैट मोमेंटम, इसका पी इस डायरेक्शन में है और आर ये है. तो जनरली क्या करते हैं, आर क्रॉस पी की जगह आर परपेंडिकुलर इनटू पी ले लेते हैं अगर मोमेंटम की बात कर रहे हैं. और इसका जो इफ आई फाइंड आर क्रॉस पी, दिस इज आर एंड दिस इज पी. So r cross p will be pointing downwards, right? Angular momentum is pointing downwards. ये ध्यान रखना है क्योंकि एडिशन सब्ट्रैक्शंस कर रहे हैं. लेकिन r परपेंडिकुलर कितना होगा, ये पूरा सीधे जा रहा है, तो इसका जो परपेंडिकुलर डिस्टेंस ये हो जाएगा. और ये तुम्हें पता है क्योंकि वो सीधे स्ट्राइक कर रहा है, तो तुम्हें एक्चुअली में पता है इसका डिस्टेंस, ए बी डिस्टेंस क्या पता है, a/4 है. r परपेंडिकुलर इंटू पी, तो एम वी a/4. So this is the angular momentum before collision for this. The angular momentum for the second body is 0. Angular momentum of the second body after collision कितना होगा, angular momentum of the body, this rod, uniform rod after collision. तो यार हमें पता है कि the particle is also going like the whole rod is going like this. Now focus on the rod. Now I have certain idea कि the whole rod will also going with some velocity like this, and there will be a rotation as well of, because there will be force on this. तो एक फोर्स लगाएगा ये इधर, तो एक टॉर्क जनरेट होगा, तो उसकी वजह से एक एंगुलर मोमेंटम का आएगा कुछ. तो यहाँ पे क्या हो सकता है एंगुलर मोमेंटम, यहाँ कहानी फंस रही है. Now here, now do you know how I am thinking the problem? Thinking is important because sometimes the results might not be what you are thinking in that sort, and you have to do a lot of questions like that so that you can have a pattern. So omega and VCM I was able to get. If this is true, then VCM is just m by capital M into V. Does it make sense? Then omega I can easily find, बट मुझे ये सेंस नहीं बना रहा है मेरे को, क्योंकि रोटेशनल मोशन यहाँ कवर नहीं हो पा रहा है. लीनियर मोमेंटम कंसिडर कर दिया, तो अगर मैंने और इतना क्लियरली दे भी नहीं रखा है, कोलिजन नहीं दे रखा है कि इलास्टिक कोलिजन है या नहीं है, क्योंकि वो चीज़ है। तो कंजर्वेशन ऑफ एंगुलर मोमेंटम मेरा मन कर रहा है लगा दूँ मैं। तो यार एंगुलर मोमेंटम का फॉर्मूला भी तो पता है रिजिड बॉडी के लिए, आई ओमेगा होता है ना। कोई रोटेशन कर रहा है तो आई ओमेगा कर दो प्लस एम वी सी एम। यहाँ मुझे थोड़ा सेंस लग रहा है, ये रोटेशनल पार्ट कंसिडर कर दे रहा है, दिस इज कंसिडरिंग द लीनियर पार्ट। नाउ आई हैव गॉट दिस 1 and 3 इक्वेशन, आई गेस आई एम एबल टू सॉल्व द क्वेश्चन बाय यूजिंग दिस। सो व्हाट डिड यू गेट? So you get an equation like, so you get these two equations. Can I solve these two equations? Half m, देखो एक जगह से either so now these are equation two variables. I guess I can use this particular equation to solve. अब देखो इधर भी है ना m आ जाएगा, लेकिन वो भी तुम्हें देखना पड़ेगा कि m कैपिटल M स्मॉल m। तो मोमेंट ऑफ इनर्शिया you actually know this is I omega square. Which, how to solve these two equations actually, that's what I'm figuring out. It's very simple if you look at it, just look at it. So I have 2-3 ways. Okay, either calculate omega by taking this here, so what I will get, mva by 4 minus mvcm 1 upon I. तो यहाँ से मुझे ओमेगा आ जाएगा. I substitute omega here, little bit of lengthy calculation that's gonna be taking place here. तो यहाँ पे VCM करूँगा सेम चीज़ होगी, MCM करूँगा सेम चीज़ होगी, VCM इधर जाएगा, वो सब होगा. तो होगा थोड़ा सा तो इशू आ रहा है इसको सॉल्व करने में, क्योंकि दो इक्वेशंस आ गई हैं, एक क्वाड्रेटिक में एक लीनियर में. ओके, if I square those two equations, omega square plus v square, I'm getting something like I, because if I square this equation, m square v square a square by 16 and I square omega square makes sense. Something like this I can use. I square omega square I can directly write, and there will be an omega as well, but उसका क्या करोगे? So that is still not. So I guess I can get an answer. Let me just see that do I get a correct answer using this. Let us use AI. Let us use AI and then solve 1 and 3 equation to get omega and v. I can do it, but let's just see कि will it lead us to something. I guess I did a mistake. I get a very complicated equation. And this is coming very complicated. I'm not sure about that this could work or not. So actually what happened is when I looked at the, this looks best, right? मतलब ये भी वर्क करना चाहिए ना, कंजर्वेशन ऑफ लीनियर मोमेंटम. तो ये एक तो ये निकल गया है हमारा वेलोसिटी ऑफ सेंटर ऑफ मास. आफ्टर दैट एंगुलर वेलोसिटी के लिए I guess this conservation of energy, they have not clearly mentioned that whether it is a, so I don't know that they can use conservation of energy or not. But one thing is, because when we talk about this system, this two particle system, now why this is conservation of angular momentum, why I would have been applying this, because the external torque to the whole system is 0. So I applied both the concepts. Dp by dt is 0 and dl by dt is 0. So mva by 4 makes sense. This is the angular momentum of the particle about a, right? So this is correct actually. This part is correct. Before the rod, the uh, I omega makes sense. MV center. Oh, this doesn't make sense. This is, oh, I made a mistake actually. This is not this. This can't be. This is linear momentum. I have to write. So if this is velocity of center of mass, it can't be like this. So once we calculated linear velocity, so it's like velocity of center of mass is calculated. So when we calculate the angular momentum, what is angular momentum? Angular momentum of the rod, because particle is at rest now. Angular momentum of the rod after the collision. What is it? Actually, if you think properly, that when you calculate the angular momentum, this is due to the rotational part, right? This is if rod is rotating like this about the center of mass. But if I imagine that there is also a translatory motion, but that translatory motion has a speed like that is happening like this, and if I take the angular momentum about this point, and if I calculate the angular momentum about this point, about this particular point, what would happen? It is passing through the this. So my axis of rotation is this perpendicular to the plane. So that would give me 0, right? Because angular momentum is r cross p, right? So r and p are lining in each other. So this will give me 0. Now what will happen? I got something like this, that omega is mva by 4 into I. So actually they were independent of each other. I didn't. So this is capital M a square by 12. So I got the answer for this. Something like this. So you might have understood that we did the calculations in a way, and I actually tried to infuse how your thinking should be, because I also tried to solve it in the first go and not just feeding you with answer. Because whenever you see a question like that, you try to figure out things, you try to do the questions by applying the concept. So one of the concept that you can apply is conservation of energy, and it is giving me in quadratic. Also it's not given very much clearly it is in elastic collision not, so this looks little bit suspicious. If you consider it a two particle system, then this might have worked. We were not confident about it, but this really works. If we, because when we consider a two particle system, external force is 0, and then it must give me a change of momentum. Linear momentum should be 0, then linear momentum should be conserved. And when you compare to this thing, this also works, and so we get an answer for both the things. So it was not that. So the motion looks like really difficult, because now it is the rod is not just going a translatory motion, it's also doing the rotational motion. So angular momentum would try to come up with from both, but the one of the things get easy up when you say that angular momentum due to the translatory motion gives me a 0 when I'm calculating it about a, because a is my center of mass only. Yeah, that makes sense. So yeah, this was an interesting question. This is from SC Verma. I hope you liked it.